to continue right now, okay? So we were talking about all the steps to achieve more efficient models or efficient algorithm of AI. So it took a very long process on data science until beginning the really building the model or the intelligent model, and then you will try to visualize its performances, and then to restart the process, but only restart to rebuilding the model or changing the architecture until having those good performances to be deployed on a real product or a real application. Okay, so we will try to follow to see more details about all the process. So right now, all we have done is to introduce this field of computer science, of data science, which is AI. So actually, do you see my next screen?
No, we can't see anything.
Okay, I will try to share.
Yes, there's a diagram right now.
So we have the diagram right now, okay? Okay, so this diagram is only to tell you about the computer science process. So the computer science is just like the very big umbrella that contains data science, and then data science is the bigger umbrella that contains AI. And then we will try to talk about AI and its fields. So AI actually contains other subfields which are related to AI. So we will have some kind of learning, machine learning, symbolic learning, statistical, deep learning, computer vision, robotics, and so on. Okay, so right now there is two different aims of AI. Whether you will try to classify a problem just to make a decision about whether this thing belongs to this class or no, or you will try to predict, to have an idea about the future of things, how it can evolve, how it can um, be augmented in the future. Okay, so this is the two sides of artificial intelligence models, and it really contains really big amount of subfields. It not contains only machine learning or deep learning. It contains robotics, symbolic learnings, and all those subfields and subdomain. Okay, so right now we will try to focus on what is really what is really machine learning and deep learning. So as I told you before, so as I told you before, artificial intelligence is the engineering of making intelligent machines and programs. Okay, so it is about making intelligent machines, and then we have machine learning. So what is actually sorry about that. And then there is machine learning. So what is really machine learning? It is the ability of machines to learn without being explicitly programmed. We will try to explain more. So right now, artificial intelligence is the field of building intelligent machines and programs. And then when it comes to the machine, its ability to learn from data, to understand data, to extract features, important factors and features from the data without being programmed traditionally, we will see the difference. It is machine learning. So machine learning, it is the ability or the capability of the machine to learn from the data. Okay, and then we have deep learning. So what is deep learning? Deep learning is um, something based. Uh, I mean, when it comes to machine learning, it's a group of algorithms, and then deep learning is a kind of algorithm in the machine learning field. So it is all in the machine learning field always. But when we talk about deep learning, it is only a new architecture or a kind of algorithm that belongs always to the machine learning field. Okay, so we will try to see this kind of algorithm. Okay, so to explain more, what is it machine learning? So we already said that machine learning is the ability of the machine to learn, and it is a group or an ensemble of algorithms and methods to make the machine to give the machine the ability to learn from data. Okay, so what is actually the difference between traditional software development and machine learning? Actually, when talking about traditional software development, we were having always input data, which are the data that we are having, and then we are having the program code, the code to test or to analyze the data and to make the decision. And we upload those two to the computer to give us an output. Okay, but when it's become to machine learning, what is the difference? We will have always the input data. We will have the data, the input data, but we will have also a kind of what should be the output, or what is it the output for this kind of data. Okay, and we will feed them to the computer to give us a kind of reflection on how to make a decision, or a program code which is really the model which is the algorithm that can make the decision by only seeing the input data. Okay, we will try to explain more and more. So I will try now to add just this kind of diagrams, and please follow me just to make things simple. So we will have right here a circle, and we will have a triangle. Okay, okay, so this is a triangle and this is a circle. Okay, when it comes to traditional software development, you need now, suppose that we need now to have to classify or to classify objects in a room or something like that, and say whether it is a triangle or a circle. Okay, so when it comes to traditional software development, you will have to say to the machine or to the computer that that you have conditions. Okay, one of the condition you will always calculate the angle. So you will say to the machine, if angle is equal or is from 0 to 180. So it is just an example. So you say, then it say triangle. Okay, so this is traditional software development. You give the condition to classify the object, and you give what is the results in this kind of condition. Okay, and then you tell him else it is circle. I repeat, this is just an example to simplify things. Okay, but then when it comes to machine learning, what you will do is not to give this kind of if and else. You will not hard-coded the conditions and what are the respective results. You will instead, so in machine learning, what you will have a group of many triangles, okay, feed it to the machine, and also a group of many circles feed it to machine. Okay, you will have triangles different in its large, different in colors, and so on, in nature and so on. Okay, and also the same thing for the circle. So the data that you have to feed to the machine need to be really very varied, need to contain as maximum as data as you can, and also not only the quantity, you have to have a good quality of data to generate a good result. Okay, so what is actually happened to the machine? So it actually see this number of triangles, and you will have to say that this is a triangle. Okay, and this is a circle. Okay, so at the beginning you will have photos or images of triangles with their etiquettes or labels saying that it is about a triangle, and about a circle also you will have to feed in very big number of circles, and saying that all those objects are circles. Okay, are circles. Okay, of course, this is only a kind of machine learning, but I'm trying only to simplify the vision for the beginners. Okay, so at the beginning, you will try to give the machine this kind of data, okay, which is known by labeled data. Okay, it is data that contains the object itself and its class or its node. Okay, so as it is really clear, I am talking here about a classification problem. Okay, and then you will give the machine some kind of feature extraction or some kind of algorithm to extract the features. Okay, one of the features. So one of the features will be always the angle. Okay, so you will say that feature angle. So you will say to the machine that you have to calculate the angle. Okay, how you will say that to the machine? Of course, by a function. Okay, so you will inform the machine that it have to calculate the angle, and then it will calculate the angle each time, every time seeing the triangle and every time seeing the circle. And it will understand step by step that whenever it is between 0 and 30, 60 or 180, it is about a triangle. When there is no angle, it is about a circle. Okay, so it will understand by itself. Okay, and then you will feed this kind of results to another mechanism of machine learning, a function. There is multiple algorithms of machine learning until having the results. Of course, in each step of learning, so there is the training process when you are feeding the data with the labels, and then you have the validation process within the training process. So the validation, what is it? It is the mechanism used by the machine to verify whether it can achieve a good result or no. Okay, so actually the machine calculates every time it generates the result. It calculates a kind of error. There is many metrics in this step, but the very important and very basic one is the gradient descent. Okay. So what is it, gradient descent? It is a kind of function. You will see more details in other workshops. It is a kind of functions to calculate the error between the generated result and the actually what it have to be, or the actual result or the original result. Okay, there is always the original one, y, and your generated result. Okay, and there is always a kind of let's say delta y, which is the variation or the difference between the two outputs. Okay, it is kind of calculating each time whether it is really approaching to learning from data and generating a good result. Okay, so when it is approaching to 0, so the machine, we can say that the machine, so it is not equal to 0, it is approaching, always approaching to 0. So we can say that the machine really learns to to good, and then we came to testing it. So what is testing? We will give a triangle, but this time it is not the same triangles used in the same data, because at the very beginning we were dividing the data set on some data for training and validation and some other data for the testing process. So we will have now another triangle, let's say, but it will be let's say it will be maybe red. Okay, so it will be a really new triangle. Okay, and then we will feed it to the machine and see whether it can say that it is a triangle or no. Okay, then that's how we will test the machine. So testing it is about using new data and which is not labeled, okay? So training, it is about using data which is labeled with the label. Validation, it is data without label, but the data within the same division, okay? When it comes to test, it is truly new data, okay, and without the label, okay? So this is just to simplify things to you, okay? So for machine learning, you need to say that this, you will not say that if you find this, you will say that. You will not use the condition, but you will try to give the machine how to calculate the feature, how to extract the feature, the main factor to make the decision, okay? But when it comes to the other field, which is deep learning, we will not really use this, okay? So when it comes to deep learning, we will not try to give the machine how to extract the feature. We will only give it the input, okay? This is the input data and the output. In this case, we will give it a bunch very massive data of triangle. I mean triangles in every color, in every directions, in every nature, and so on, and also a big number of circles. Okay, and we will give it the label always for the training. So label data, saying that this is a triangle and this is a circle. Okay, and then we will let the machine decide by itself. All the programmer or developer can do here is to choose the architecture, okay, the architecture of the deep learning algorithm, because here there is a big number of architecture you will see in details in other workshops, okay? It depends on the kind of functions, put it right here to have the final architecture of the network, okay? So it is about neural networks because it is trying to simulate how the brain of the human being is working. Okay, so it is a kind of node which are connected one by one until having this very complex architecture of networks which are very similar to the neurons in brain, in a human being brain, which are called neural networks. Okay, so in deep learning, you will have the input, the labeled data, and you will have only to feed this to the model or to the architecture choose to explore and to decide and to classify the data, and you will have the output. In each time, there is always the calculation to from the machine to know whether it can achieve a good result or no. And by the end, when we will have the model, we can measure its performance or efficiency by using some kind of metrics, which are some functions, mathematical functions, to decide the better architecture or the best architecture to use, the best model to use, and so on. Okay, so to repeat, traditional software development is about hard coding the conditions to make the machine able to decide or to classify or to predict. Okay, when it comes to machine learning, you will have to feed in the data and the output. And you will just use some functions to give the machine the ability to extract the features, the main features in the data, and then it will develop her way to give us the model. When it comes to deep learning, we will give the data only the inputs, the labeled data, and the architecture of the network, the neural network used, the used neural network, and we will have the decision. Okay, so this is the hard process. I was only using some very basic kind of simplifications to help you understand more. So please, I will have some time for questions. If you have any questions, please let me know. And also, we will have discussions on our slides. Please be generous and ask questions. And also, experienced collaborators and participants, please try to help you each other. Please try to respond by you, and then to have nice discussions about that, and also to share some good resources. Okay, so finally I will repeat the process. So when talking about creating the model, we have to design the project. We have to decide on our targets, on our nature of data to work with, on our architecture of model to work with, and so on. Okay, and then we will have the feature engineering, the data, before that the data cleansing and wrangling, exploring the data and the pre-processing the data, and so on. We will have the feature engineering and labeling of the data. And then we will try to feed in the data to the model, to the chosen architecture. And then we will try to start the predictions, to test the model, and then to repeat the process if it is necessary, if we are not really having a good results. And then we can, when achieving a good result, we can proceed on the deployment. Okay, so just only here I have the splitting. I forget to talk about this. So when I was talking about the training and testing, so this is the concept. I will try to use it here just to be clear. So what is this? That so actually supposing that we have the data set, we have 100% of data. Okay, so actually it is just an example. It is kind of depending on our use case and what are really our needs and targeted. But in general, it can take about 80% for the training. So this 80%, it is the data with the labels. Okay, this is for training. And then we will have 20%. This is the data for testing. Okay, the data without labels. Okay, so you can see here that are that are divided from the very beginning. So for the model or for the machine, those data can be totally new from this data, from the training data. Okay, and then when it comes to the validation, it is I mean a process within the training. So we will divide the labeled data, the data with the label, to the training, about 18 or 70% of data. And then we will have the same data here that we were having here, but without labels for validation. So each time the model will learn from here and test himself here within data without labels. So here he will have the data, it will have the data and the labels, and here it will try to validate itself. So it will have to generate the result, which is kind of generating the label for the data, for the same data. And then when achieving a good result, we will move on to testing. We will feed in truly new data to the model to see whether it is capable to detect or to classify or to predict the data. Okay, so this is the whole process. I really hope that it was clear.